Hello 8th grade, my name is Mr. Rogers and you are watching the video lecture for section 1-2 in your book. This is on heat transfer and we're going to focus on that convection is our major type we're going to focus on. So our lesson objectives for the day are to 1, identify the different types of heat transfer, and 2, explain how convection currents happen in the mantle. So let's get right to it. So we have 3 different types of heat transfer, and the first one's going to be radiation. So we have radiation, conduction, and convection. We're going to focus on radiation first. Radiation is the transfer of energy through empty space. So again, think about this time of year, we have our sun heating up, melting all of our snow, almost all gone. That's radiation. That heat from the sun travels through millions of open space, millions of miles of open space till it gets to Earth, through our atmosphere, and us. So it's that radiation. There's actually nothing transferring it. Just the energy of the radiation itself is carrying it to us. So that's our first type. Our second type is known as conduction. So conduction is the heat transfer by direct contact. You actually have to be touching. So think of touching a hot stove or a plate. If you have an electric stove, that heating element is probably touching the pan. That's conduction. I have my silly little picture there. And if you have that metal handle for when you're cooking your marshmallows for s'mores, and there's no kind of wood at the end, over time, the heat's going to travel down through conduction, that direct contact, until you get burned. Now, our final type then for the day we're going to focus on here is really convection is the big one. Convection is heat transfer by the movement of a heated fluid. And so when we talk about heat transfer, heat's being transferred from one place to another. So with our radiation, energy from the sun is coming to the earth. For conduction, as heat's traveling down something by direct contact. And then here in convection, it's that transfer by a heated fluid. So again, this could be a liquid or a gas. In our case, we're kind of talking about liquid rock, or almost liquid rock is what we're focusing on. And so what we're talking about is convection. So boiling water, it's how water boils. The heat starts at the bottom, rises, cools, and falls. And we're going to focus on this idea of a convection and convection. So convection. Convection is the heating and cooling of the fluid. So changes in the fluid's density and the force of gravity combine to set convection currents in motion in the Earth's mantle, the asthenosphere. So what happens here is the warmer magma rises toward the asthenosphere, through the asthenosphere near the lithosphere, and the older, more dense will sink back down into the Earth. I'm going to take a bigger look at this in a video I'm going to attach to this video lecture. So we're going to stop here, guys. We'll have one more video to watch and take notes on. And we thank you guys for watching, and we will see you along the way. Hello 8th grade. Welcome. Today we are talking about convection currents. I want to show you this picture here of, again, the cross section of the Earth. And we're really focusing on some major areas. So right here in the middle, we're focusing on what's happening here, what's happening here, and also kind of right along there. So we're focusing on these 3 major areas. And what we're looking for is the idea of convection. So convection, again, is when that warmer material, when it gets heated up, so our warmer magma, and again, we're in the asthenosphere, not so far deep in the mantle. Typically, this happens more at the top of the asthenosphere, not deeper in the mantle. So what's happening? Well, deep in the mantle, we're going to be looking kind of right down here is where we're going to start. And what's happening is when the rock material is deeper in the earth, it's obviously hotter. The deeper you go, the hotter it is. And so as this material is near the core, or deeper in the mantle, it begins to heat up. And at a certain point, again, that density is going to change. When you heat something up, the particles start to spread out more and more. They're more and more spread out. And so that allows it to rise through the more dense rock around it. And when it hits the surface right here, when it hits the surface right about there, that'd be the lithosphere, that solid rock. Obviously it can't go up anymore, so you can see from the arrows it goes to the left or goes to the right. And again, over millions and millions of years this happens. That rock is being pulled away from that area and being pulled back down. And then when it hits another plate, like right there, now the rock is much more dense. It's had millions and millions of years to cool, and so now those particles are going to be much tighter together. They're much tighter together. So they are more dense and they are going to sink deep into the mantle. And so this idea of a convection current, where the warmer material is going to rise, the colder sinks. And that creates that current. It's called a convection current, where the warm, less dense material will rise, the colder, more dense material is going to sink deep into the earth. And that's the idea of a convection current. So we're going to stop there, guys, and I thank you for watching.